Good afternoon, everybody. I got a full house. Hope everyone's doing well. It's weird. Just 6 months ago, we did this AWE. It's come so soon, so it's just kind of a bit of a shock to be here again, but it's great to be here and great to see everybody live. Metaverse. So everyone's talking about Metaverse. Figure I better put Metaverse on the slide, or else someone's going to come to my talk, so that's why I have the Metaverse there. What I want to talk about today, a couple of things in all seriousness. I want to talk about Metaverse, but really I want to talk about the gateways to Metaverse, because in this talk we talked about various aspects of Metaverse, how you build it, how you navigate in it, what it means, how society profit from it, and so on and so forth. But at the end of the day, you need to be able to go into this digital world, in this virtual world, and of course the natural way is through AR and ER displays. That's the title of my talk. But I do want to spend a little bit of time, maybe a few slides on the Metaverse, so that I set the stage for what's going to come next, not just in terms of near-eye displays, but a whole complementary technology that needs to come together to enable the modalities of interaction and the modalities of movement and the modalities of integration with the Metaverse. And so over the next 3, 4, 5, 6 months, I want to talk more and more about the whole entire Metaverse framework and the technological foundations that'll enable that. But today I want to focus more on near-eye displays, but I'll motivate the discussion at a higher level of abstraction first, then sort of drill down into more tangible things. Okay, so I'm not going to read this. What's a Metaverse? I don't know. I don't think anybody knows, quite frankly. I've heard many definitions here today, and it'll continue to have new definitions. What I do like is what Matthew Ball said down here in the yellow box. And the key things I take out of there are these 4 or 5 elements. That it's a massively scaled and interoperable network. It's really important, again, for technological foundational basis. It is real-time virtual worlds. Again, real-time, really important. It is synchronous. It is persistence. And it's continuous. Those are all very, very important words, because that really then starts to think about if you want to have all of those things occurring or enabled, you need to have foundational technological bases that allow that to occur. And it's quite tricky, and that'll sort of inform the industry of where we invest and what we have to develop in the coming months and years and beyond, in order to enable and facilitate that vision. So structural framework for the Metaverse. Here's sort of our view of the Metaverse, my view of the Metaverse. We can argue or not, but this is the way I look at it. It's very simple. I like simple things. And so I think about Metaverse at the highest level of abstraction of spaces, places, peoples, and objects. So spaces have places, and places consist of people and objects. And all these things have to work together to interact. They have presence, they have interaction, and the ability to do all that is absolutely part and parcel of the experience. The ability to coexist and cohabit both the real world and a virtual world, and to do it seamlessly and synchronously and continuously and so on and so forth, means that you have to be able the ability to have to interact and have presence and perception and interaction. And to do that requires a core base of technology to have to come together to enable that. In order to enable those modalities, you have to have sensing. You have to know where you are, where things are, how things work or communicate with each other, how things see each other. And you have to have actuation, because you want to actually feel things in the Metaverse and touch things in the Metaverse. You have to have actuation, some way of feeling. So you have to have actuation, you have to have sensing, you have massive computing, obviously, and you'll be able to connect. And those elements have to come together, and then they'll then further define underlying technologies that need to come together to enable the higher level modalities, and finally the existence of this Metaverse of spaces, places, peoples, and objects. So that's really the motivation behind this. Again, I'm not going to go into all that today, because that's a long discussion, but that's the foundation of what we'll talk about in the next coming months and years as we flesh out the technologies that can enable that vision. And what the Metaverse becomes, I don't care, honestly. I mean, what it looks like, no one knows. Just like no one knew what the internet would be like today, when it was first conceived maybe 30 years ago, 40 years ago, will be so for the Metaverse as well. But how it unfolds, you have to have these capabilities. You have to be able to build worlds, be able to live in that world, live in this world in a very seamless, continuous way. And that's where technological aspects come into it. So that's sort of my sort of pitch for down the road. So more about here and why I'm here today to talk to you. it's sort of talk about the gateways to the metaverse. How do you get into the metaverse? How do you enter this world? How do you coexist with this world? How do you move around this world? How do you interact with this world? And the real world, how do you do both, right? And so this you all know very well. Clearly, there are many ways to getting in there. You have your standard devices, your PCs, your laptops, your cell phones, and so on and so forth. It's not very immersive, but it's practical and it works. But then there's also a little more immersion, if you will. Then you have AR glasses, then you have some wearable devices, you have smart watches, you have smart clothing coming out now. And then, of course, you want to get more immersive and fully occluded view of the world, then you have your VR glasses, your headsets, and other new devices that are coming out in the future. But I'm here to talk about first steps first. How do you sort of first get into the metaverse in a very simple way today with where we are, with what's needed, what's necessary, and what's available and what's capable, is that's going through really augmented reality. Okay? And that's what I'll talk about today, and the technologies behind that. Okay, so a tale of two worlds, a dichotomy. In the world of AR today, we have lots of real great companies here talking about both parts of the world. One part of the world is what I call practical and useful. In the other part of the world, I won't say it's impractical, but it's niche and it's very, very immersive. What I mean by that is that you've got this whole notion of smart glass that you put on, and it's a simple device like any other pair of glasses, and it gives you information for your daily needs, if you will. Then on the other end of the spectrum, we have a much more sophisticated device, like the HoloLens, like the Magic Leap that some of you probably saw, that's much more immersive, much more niche, and it's much very, very powerful, but they're really two separate worlds with two separate needs and two separate technological foundational bases to allow that kind of performance to occur. In the case of a smart glass type of device, a simple AR device, it's a device you want to wear all day long. It has to be very light, of course. It want to be fast. Most of them don't look funny when you're walking around with these glasses. It has to work inside. It has to work outside. It has to be low power. Very, very simple. Small, lightweight, low power, all-day wearable, useful information. On the other hand, when you want to get something much more immersive, then you have to have much, much higher resolution. You have to have much larger fields of view. You need to have, really behave as the human eye behaves in many ways. And so they're really two different aspects. And I would argue that, if you want to proliferate the metaverse, whatever that means, you want to proliferate augmented reality and be able to live and coexist in a digital world and a physical world at the same time, and without obstruction, I would tell you smart glass is probably the places to start, and over time you'll evolve that. So when you think about this, then what drives form factor? What are we trying to achieve, and where are we today? And so in this spectrum over here, in this graph over here, it just shows you basically size as it gets smaller on the x-axis as you're going out the x-axis, and immersivity on the y-axis. And the whole idea is we want everything. We want to have the lightest, smallest device allowing full immersion. You want to be able to do everything you can. You want to interact with the environment seamlessly. You want things to be world locked. You want things to be continuous. You want persistence. You want all these great things, but you want to have something very small, which is not there yet today. The Holy Grail, of course, is always up and to the right, as they say. These are all companies. I didn't put the companies' names in it. You know who you are, who they are, but basically you've got various levels of sophistication of immersivity versus size, and certainly as it gets smaller and slides today, we are at a spot of what I call smart glasses, really a wearable head-up display, which gives you informatics for your applications that you need. But trying to get up to the right is really challenging. I'll talk about later what that means and how you get there and what it requires to get there. But this is the dilemma that the industry faces today in terms of size versus performance. But I'll once again argue that we need to, if you want to, again, get the metaverse going, you want to get AR going, you want a pair of devices that have utility for the average user to wear all day long, ostensibly. I want to just switch gears here to talk about the market. There's two different views of the market. One is a little bit dated. This is Yole from 2020, and on the right-hand side is this last month from this is from ABI Research. And so what this shows is basically, where do these folks see the market headed? Who is using it, or what kind of use cases are there? And so in both cases, again, you can debate the numbers. I'm not going to debate the numbers, are they right, are they wrong, doesn't matter. What matters more is the vector, where people think things are headed. And in both cases, it points to the fact that the use cases that makes the most sense is really the enterprise, industrial, pedagogical, and those non-consumer use cases. And that is where we've actually found, talking to a lot of end customers and companies, where the most needs are and the use cases are. But I'll also tell you that it's a great place to start because, as you saw earlier about the industrial use of Metaverse, it's really important because in that space, not only is there a need, but you also learn in a very controlled fashion what works, what does not work, what modalities of interaction and engagement and the device, how the people work with it. You can very quickly take that and iterate that into your product design. So when the consumer is ready, you've debugged all these modalities that are necessary to understand in terms of how do I work in this virtual space as a user interacting with that. Okay, so what are some of the requirements here that we work at? So if you look at both sides, a couple of key things that are really important. So again, on a smart glasses kind of a device you want to wear all day long on a factory floor or out in the field or where have you, it has to be all day wearable for sure, whereas AR/MR, or XR/MR I should say, is much more task specific. So I'm doing a task for an hour or two and I'm done, essentially. Clearly for smart glasses, I want to have it outside, inside, all day long. Whereas if I'm working on some task-specific thing, typically it's indoors. What that then means is that how bright does it have to be? So the brightness then informs the use case. So in the case of smart glasses, you need to be over 1,000 nits or 1,000 candles per square meter, whereas in the case of XR/MR, it's a little half of that much. There's some caveats here you can read. I won't go into detail. And I won't go through every single spec here, but the whole point is that there's two different requirements for these two sets of applications. And that's what really drives the underlying technology in terms of what's needed to deliver that kind of capability. And so when you want to go from the left to the right, from a very immersive device to have immersivity on a pair of glasses, there's a lot of challenges. We're nowhere near that space today. It's not a question of technology, but it's a question of integration, power, and a lot of other complexity. That day will come eventually. Just not here today, and people are working towards that. But regardless of what the end use happens to be in terms of use cases, you need to have a compact, lightweight, high brightness display. You need to have very highly efficient combiner optics. That is the optics that takes the data from the projector or display and brings it to your eye. You have to have very low latency, you have to have low power, and very high brightness. And so what we work on at ST is something called laser beam scan technology, and we believe that's a technology we can deliver all those critical needs. There's also micro LEDs, a lot of you talk about, a lot of people work in that space, some of you may work in that space. Great technology, it's many, many years out in terms of maturity. That day will come, but for today, these are the dominant technologies, typically DLP, LCOS, some micro OLED, and then laser beam scanning. And we really believe laser beam scanning is the one that can really, it does in fact support both needs. But again, I want to make the point that it's not just a display. You have to have a lot of other things come together, a lot of complicated image sensors, motion sensors, very high compute, very high bandwidth, low latency communication. Lots of things have to happen above and beyond just the display itself. But the display portion certainly can be addressed with this technology. And so, and the reason why is basically, if you plot sort of the performance in terms of field of view, and this is one measure people always talk about in our business, versus size of the device, laser beam scanning maintains, it's very scalable, maintains the same sort of volumetric profile as the performance is bigger, the device maintains its geometry and maintains its size. And so, this is an illustration of how it works. Like, for those who don't know, laser beam scanning. So basically what you have over here is red, green, and blue lasers. They're emitted and they're collimated, goes through a combining set of lenses. And the collinear beams hits one or two mirrors. The mirrors scan back and forth, hits a display or hits a optical element, and then it goes into your eye. That's the principles of laser beam scanning technology. So how does that work? What's under there? What's the engine that really drives the laser beam scanning? It's really composed of several elements. So we do have something called the ScanR family of products. That stands for MEMS scanning for AR. MEMS, for those of you who don't know, is a microelectromechanical device. So that is a very, very small device. And so we basically have two elements for laser beam scanning. You have a photonics that we call the optical light engine, and electronic subsystems. And those two together come together in a very small form factor in order to deliver the performance that you need in a pair of glasses that you see over here. We are in booth 413, I believe, so come check it out. We have some examples of the glasses, and you can see for yourself how small it is, how compact it is. And the point of this is that we use advanced technologies. We use something called piezoelectric technology, thin film piezoelectric technology to be specific. And with that, we're able to achieve a very good performance in terms of resolution, in terms of field of view, range of brightness, and so on. And as a company, we are a semiconductor company, so we invest quite a bit in terms of the future technologies. We want to get better and better, higher field of view, higher resolution, lower power, smaller size. So we invest a lot of money and resources on improving our process technology, our material systems, our material technology, and our overall architecture of the end device. So I won't go into a lot of detail here. Suffice it to say that as a semiconductor company, we invest quite a bit, always pushing the process and pushing the material sciences forward in order to achieve the performance required. So when you want to go to really deeply immersive AR, you want to get much higher fields of view and much higher resolution. We have a roadmap that can address that when that day comes, in terms of mass market availability of such products. So a lot of these have to come together. So in order to be able to even deliver this, just a pair of glasses with the display portion alone, as well as some of the functionality, a lot of stuff has to come together, and it's not for the faint of heart. That's why a lot of the big companies spend a lot of R&D, a lot of effort to do this. And there's more than just this at a simple level. All this has to come together. And so, although we do a lot of stuff in our company, we also don't do a lot of these things. And then we partner. So we make sure that we want to enable the marketplace by developing partnerships with other like companies and even our competitors to make sure that we can actually have a market that can proliferate and thrive. So to that extent, I would say it takes a village. We created an alliance recently. It's a nonprofit group. I think that did up to 20 members right now and counting, and I'm not going to go through all these details here, but the point here is that somebody in the last talk asked a question about standards. We want to think about creating standards. We want to create harmonized activities, harmonized efforts, and harmonized technologies that can actually work together. And so that way, when end companies go to build products, they then have a ready supply of devices and technologies and solutions and systems that they can bring to bear. But that's not so. And I'll leave with this chart, and I'll take some questions. But I want to talk about is, the displays aren't enough. A lot of sophisticated technologies come together, as I mentioned earlier, right? So to have even some simple interaction and simple applications, you have to have not just displays, you have to have time-of-flight sensors, you need to have image sensors, you need to have motion MEMS, you need to have a whole range of products and solutions that need to come together. You have to have small microphones, you have to have small speakers, the list goes on and on. So the teaser is, stay tuned, but over time you'll see more and more of these technologies being integrated and giving much richer experiences. But what I want to leave with you today is really a couple of things, is that, to get in the metaverse, you need to have a simple way of doing it. If you do it with a very complicated headset, which I don't knock, they're beautiful devices, you won't proliferate as much. So my position is get smart glasses, start developing applications, deploy it where people need to use it, particularly in non-consumer segments. Learn how the modalities of interactions work. Learn how people use these things. Learn how they interact with these things. Learn what you need to do in terms of how you'll move in this space. And then that learning can then quickly translate into a consumer domain as well. So with that, I've got 5 minutes for Q&A. So I hope that was interesting for you guys. I just thank you for your listening to me. And with that, guys, jump in and just ask anything you'd like. Thank you.
It's very informative. Thanks. What's the biggest challenge for you to send this to the consumer? LBS-based glasses.
It's not even LBS. The biggest challenge, I'll tell you, and I will challenge anybody's point. What does the consumer want to do? No one has answered the question yet. What does a consumer do with this stuff? An average, not techies in this room, right? An average consumer, What will they do with this product, right? So the challenge for us, really, quite frankly, technology is not the challenge for us. It's understanding how do people use it, what will they use with it, how will they interact with it. And there's 1,000 different answers, and there's no clear one answer. I'll say this to you as well. If there was a killer app, Apple would already do it now, right? The technology is available today. Whether it's laser beam scanning, others, the technology is there to actually deliver this. The question now is that, well, so what? That's the so what you have to answer, right? What is the consumer going to do? That's why I come back saying, what? Instead of the consumer, let's think about people who actually can use it. That's the enterprise industrial architecture, engineering, construction, repair and maintenance, factory, warehouse, logistics. They could use it. And that's where we should drive and not jump to the consumer because we don't know what the consumer wants. I don't know, quite frankly, what the consumer wants to do with this stuff.
How long do you think that may take? A couple of years, a couple of years?
That's a crystal ball question. Who knows? Everyone says 2025. It's always 2025. It's almost there now, right? So is it? I don't know. Honestly speaking, it's coming soon, right? That's all I can say. It's not many years, right? But you got to crack that nut. What would your grandmother do with this stuff, right? If you can answer that question, then we'd know. But I also say again, there are other use cases for sure that that can help answer some of that.
Thanks.
Thank you for your question. Any other?
Are there limits or issues regarding eye safety, regarding laser beam scanning? Because I know from the mobile projectors, there was also a big limitation for laser beam technology.
That's a great question. The answer is not for near eye because we work with very low power lasers. You're absolutely correct. In the case of Pico projector, for example, there are a lot of limitations because of eye safety and the high brightness because you need a very high brightness for a projector in a wall of this size. But not here, not in this side. We are working much lower power lasers.
Even not regarding large field of use because only the scaling would change.
Correct. Exactly, that's correct. A good question, though. Anybody else? Any other comments or questions? Okay.
Hi,
Hello.
thanks for the talk. I'm curious how much you see the focus being on display technologies as opposed to some of the other things like scanning or interface or other areas for improvement.
Yeah, I think that, in my opinion, again, right, my own personal opinion, I think there's an inordinate amount of time spent on the display side, right? And I think we got to start spending a lot more time on modalities of use and how do I use this thing. And again, the technologies exist. It's not a technological question. It's a use case question. And I would like to see people spend more time. In fact, at ST, we started working with the partners at the very end, saying, how do you use this stuff? What do you do with these things? Technologies exist. Are you gonna tap? Are you going to go out in free space and gesture and gesticulate? What do you do? And I think we should spend more time understanding that as well. And that's, I think, part of the problem is that last mile is hard last mile. But display technology, there's a ton of money being spent on it. There's a ton of great companies working on it. Aside from us. So I think that problem, I don't want to say solved, but that problem is an engineering problem, not an R&D problem, I would say. Terrific. Anybody else? Any other comments? Comments are also welcome. Even criticisms is fine. It's okay.
Hi.
Hello.
Great presentation.
Thank you.
So can you give any estimates on average power consumption for these?
Sure. So today, for a laser beam scan system, we're under 500 milliwatts.
500.
Yeah. That's based on 25% duty cycle, meaning that most of the content is sparse. And the reason why it's so low is that, as you can imagine, we do laser beam scanning. You only turn the laser on where there's brightness, where there's some information. When there's nothing there, the laser's turned off, and that way you have a much lower power. And so, and you're not watching a movie, you're doing a PowerPoint slide, you're typically looking at an informatic display, and that typically doesn't take up the entire display. And so, based on that, we're less than 500 milliwatts today.
Thanks.
Thank you. And the idea is to basically run, 20%. The thought is to really have a 20% duty cycle use case for 8 hour a day use. So you're not going to have this thing on all the time, right? So roughly a quarter of the time you'll be using it. It's the thought process.
Sorry. In one of the slides, you showed an optical relay. Is there any reason for that?
So what's the question again? I'm sorry.
I think you had an optical relay.
Relay, right?
Yes. Is there any reason for that?
Yes, it depends. That's a really good question. So the relay optics is really a function of the kind of combiner you use. So as you know very well, if there's guided wave, there's non-guided wave way of combining. And so certain waveguides will require a different beam profile to be coupled into it. Particularly speaking, diffractive waveguides have an input coupler that has a certain size and dimension and a geometry around it. And so depending on that, you want to get the maximum fill factor into that element. And so depending on that, you may have to have relay optics to shape the beam in order to fit the profile of the in-coupler of a diffractive waveguide, for example.
Okay. So you are expanding the beam as well?
Yes, expanding, shaping it, depending on the need, right? The answer is yes. It just depends upon the particular in-coupler in mind. But yes, in general, it's beam expansion and or beam shaping.
Okay. That leads me to the other related parameter, which is field of view.
Uh-huh.
If you expand the beam, then let's say if you double the beam size, you are at the same time reducing the field of view by half. And you are showing quite a large field of view. So what is the input field of view you can get out of the projector itself?
The projector today is a 65 degrees diagonal field of view. That's what's without the optical field of view of the projector itself. And then depending on the optical system, you may go a little lower, just depending on the optics of the waveguide itself. But the projector itself today is a 65 degree diagonal.
Okay, thank you.
You're welcome. Anybody else?
Hello? Hi.
Hello.
You made a good point of separating between the AR and then what you called XR, or like other people call it MR devices, and stating that it's first important to focus on the AR, small, low power, and then transverse into the other domain. I was curious on your thoughts of like, because of the intrinsic like technologies that come to getting to that other domain, if starting with the simple devices and then transferring it over would actually do the proper transfer, or because you would need a whole lot of technology to go through there?
I think, my views is that you start with a simple device and you build up to it, right? Because the most constraint is the little guy. It's easy to build a big guy. I mean, easy in quotes, right? They say, you don't care about power, you don't care about size or weight, you can just throw stuff in there. So it's a lot more complicated to do here. So I always say start step by step. Have a display, have simple interactivity, and later on add on to it more and more within the constraint and try to find solutions around that, right? Whether it's power or size or thermal management or something else. So in my opinion, my experience is always to build up that way and transfer that functionality that way. Because they're two domains, right? You're not constrained in again, it's a great product, HoloLens, but not constrained as much as you want a pair of glasses. And so solving that problem will solve that problem for sure, right? So that's the way I view it, right? You want to solve here first, Here meaning the simpler AR.
Thank you.
Thank you. We're out of time. Sorry, I didn't even check the clock. I'm so sorry about that. So listen, thanks, guys. Really appreciate the questions and you listening to me. And I'm around. We're at booth 413. Questions always welcome. So thank you all very much for listening. Appreciate it.